If I remember correctly, wasn't the last problem a factoring problem?
Yeah, number 3.
Yeah, okay. So this can kind of be seen as an extension of that discussion. Okay, so what I'm gonna do, we're gonna talk about factoring right now, then we're gonna take the little tour. While Maria is talking to you about how the Math Science Center works, because she's gonna kind of do that, I'm gonna be in my office and print out a factoring handout that will help you with the methods of factoring. Okay. What we talked about last time, let me kind of build back up to it. We talked about difference of squares, but where we start with factoring is we start with GCF. So like, for example, hey, if I wanted to factor that. So when you first learn GCF, what I like to call it, even before I call it GCF, if I'm teaching like back in the day when we were allowed to teach elementary algebra, I would tell them, we're gonna do undistribution. Because when you distribute, you multiply something in. So GCF is really taking that back out. So real quick, if I wanted to simplify this, what would you do?
5y squared.
Yeah, you would multiply it in 5y squared. That's 35. Y. Now, this is kind of a silly question, but what do they both have in common? What number do they have in common? 5 and a y. And of course they do, because that's the thing I gave both of them, yes? So on one level, that question is really silly, especially when I do this. You gave both of them a 5y, so they both have 5y, Jeff. Okay, groundbreaking. This problem is a little harder, because they didn't show you where it came from. But can you still tell me what number do they have in common? 6 goes into both. And yeah, if I try to take out 2 x's, x squared, wouldn't this guy freak out? Okay. So I always think of this as being like the almost fair tax man. I'll take everything you got, but not more, right? So like when you run out of money in the bank charges you an overdraft fee, and you're like, did you miss where I don't have money? Right. So I know that experience all too well. Thankfully, not recently. College was interesting. So if I take out a 6x, what's left? It's just an x. So this part just has this left, right? Because the 6 came out, one of the x's came out. What does this guy have left? 8. Okay, good. So that is GCF. That's greatest common factor. And it doesn't matter how many terms you have. That just makes it more things to consider. You're still trying to come up with what number and what letters could I take out of everybody? And then you do it. Okay. Then you graduate to this kind of thing. What do you got, Jeff? I don't know, Jeff. How many terms are there? How many terms?
4.
Hmm?
I said 4.
4, yes, thank you. There's 4 terms. If you ever have 4 or more terms, you try something called grouping. Does that sound familiar? Okay. One little thing about the way it's traditionally taught is people put parentheses, and that's silly. If I put parentheses, I'd have to remember to take a negative out. So I just say these 2 and these 2. What comes out of these 2? Yeah, I could take 2 x's out of both, and they both would still be okay. Neither one freaks out. So what's left here? And what's left here? 4, yes. What comes out of these 2?
9.
Yeah, a 9. Now here's the trick. I want these 2 things to be the same, because then I can go one more step. If those are both the same, I could take it out. You took it out. If I take a 9 out, don't I get negative x plus 4? Is that the same as this?
No.
So what should I take out? Not just 9, but negative 9. Then that would change both signs. Okay. So if you take a negative 9 out, what's left? X minus 4. Get 36 divided by negative 9 is negative 4. I know I'm on the right track because these two are the same. Does this feel familiar to anyone? Okay.
Familiar.
So if I take out an x minus 4, what's left? X squared. Well, it's not yet, so you can literally just cover it up and see what's left. And then to check myself, if I distribute this, x minus 4 times x squared, it's right there. X minus 4 times negative 9, it's right there, yeah? Can we stop for a second? So this is a trippy GCF. Do they share any numbers? No. Does this guy have any x's? That's where you gotta be careful. Does this guy have any x's? No. He's got a 9, and he's got an x minus 4. Yes? Does he have an x minus 4? Does he have an x minus 4? Totally. So they have something in common, GCF, it can come out. Somebody must have distributed it. Let me take it back out. How are you guys doing? And again, does this feel familiar to anybody? Yes? Okay. Now, I could do one more step and see if you guys remember. What is this?
It's x plus or x.
Yeah. So this guy just comes to the right. X squared is x times x, yes? This is a difference of squares. So break 9 up in half multiplicatively. It's 3 and 3. And then like you said back there, plus minus. Yes, no, maybe? Screen Jeff? And I think last night I showed you if you pick a value of x, if I plug it in here, I get a number. And if I plug it down here, I get a way to factor that number. Like you put 7 in for x, this will be a number, correct? 7 cubed minus blah, blah, blah. And then if you put a 7 here, 3 times 10 times 4, that's one way to factor that number you had. That's what we did last night, yes? Okay, I love you guys. All right. Then, let's do one more form and then we'll go on our little tour. We get this type of problem. Does this look familiar to anybody? Okay, so it's a lot like this difference of squares, except the middle term did not cancel, correct? The middle term is still alive. Do you guys remember what kind of a number game this becomes? Like x squared, what's the only thing that can make x squared? X and x. So the whole question then is, how do I break 4 up so it not only becomes 4, but it also becomes 5 in the right way? I don't know if you guys understand what I'm saying. I need to break 4 up, so I get two numbers that multiply by 4, but what else must they do? Add up to be 5. Maybe? No? Because remember, if I FOIL two things, I get x squared plus 5x plus 2x plus 10. Where'd the 10 come from? 2 times 5. And where the 7 come from that I get next? 2 plus 5. You guys with me? So it becomes a number game. What two numbers not only multiply to be 4, but also add to be 5?
4 and 1.
4 and 1, yeah. So this one's not too bad. And then if you multiply it out, you'll get x squared plus x plus 4x plus 4. You'll get x squared plus 5x plus 4. You'll get what you're supposed to get. Okay, I like it. So you can always check the results of a factoring problem by just multiplying it back out. So let's do this. I didn't come with my little factoring handout because I didn't think I wanted to start with that. Let's do our little tour since I got more people.